we are going to learn about linearly dependent and independent vectors. Now first we will be focusing on linearly independent and then we will be focusing on the linearly dependent vector. Now first of all, try to understand what we mean by a vector. Now vectors will be denoted by letter V generally, and in this we are going to have a set of numbers. For example, we are having 2, 3 and 5. Now when it comes to the vectors will be having some fixed number of elements in it. Those are going to be the numbers. They may be positive, negative, or any number. Now this one, if these are having 3 elements, so we say that this is a vector of 3 tuple size. Number of element present in that is 3, so we write 3 tuples. Now when it comes to the defining a vector is a set of numbers arranged in a fixed order, and the number of element present in that is called as that n tuple. So if there are 3 elements, we call that as a 3 tuple. If it is a 4 element, we call that as a 4 tuples. Let us take another vector, that is v2, that is a 0, 1, 2, 4. Now there are how many elements in this? 1, 2, 3, 4. 4 elements are there, so we call this as a 4 tuples. So the vectors are nothing but a set of elements arranged in a fixed order, and the number of elements present in that are called as a tuples of that. That is a 3 tuple, 4 tuple, 5 tuple as per the number of elements present in that vector. Now when it comes to adding 2 vectors or subtracting 2 vectors, we need to have both the vector of same tuple. That means the number of elements present in the first vector need to be the same as number of elements present in the second vector. That is the main criteria for finding the addition, for doing addition and subtraction of the 2 vectors. Now let us have an example of that. Take the vector v3, that is 0, 2, 4 and 6. Now suppose we want to add v2 with v3. Now what is going to be the answer for that? See, first thing we need to see what is tuple of that is the number of element present in v2, that is 4 tuple. v3, it is also 4 tuple. That means we can add and subtract v2 and v3. Now v1 plus v2 plus v3, first we will write v2 elements 0, 1, 2 and 4, plus we will write next, that is v3 elements 0, 2, 4 and 6. Now when it comes to adding the 2 vectors, we are going to add the corresponding element. That means first will be added with the first one, second will be added with the second one. So we will be doing that 0 plus 0, that is the first one. Second is 1 and here second is 2. So we will be adding those 2 elements, 1 plus 2. Third element is this 2 and here third element is 4. So we will be adding those 2. 2 plus 4 and here last element will be added with the last element, that is 4 plus 6. Now we will simplify this one. 0 plus 0 is 0. 1 plus 2 is 3. 2 plus 4 is 6 and 4 plus 6 is 10. Now we got this as an answer. This is answer for v2 plus v3. Similarly, if we have to do the subtraction, we can do the subtraction in the same way. Let us see that v2 minus v3. So we will be writing v2, that is 0, 1, 2 and 4, minus v3, that is 0, 2, 4 and 6. As we did in addition, same way in the subtraction, first element will be subtracted with the first, 0 minus 0, 1 minus 2, second with the second, third element with the third element, that is 2 minus 4, and the last with the last, that is 4 minus 6. So it is going to be 0, 1 minus 2 is minus 1, 2 minus 4 is minus 2, 4 minus 6 is minus 2. This is the answer for v2 minus v3. Now we will be doing the next part, that is a scalar multiplication of the vector. Suppose we have been given a vector v4. v4, that is equal to 2, 5, minus 1 and 3. Suppose we have to find out v4. So what is going to be that? That is going to be 5 into V4 elements, that is 2, 5, minus 1 and 3. So we will be multiplying 5 inside, so 5 2s are 10, then 5 5s are 25, then 5 1s are 5 with the minus sign, minus 5, 5 3s are 15. This is going to be the answer of 5V4. Now we understood the scalar multiplication. Now we will be having scalar multiplication and addition or subtraction at a time. Let us take another example. Let us take V6, that is 1, 2 and 3. V7, that is 0, 1 and 4. Now we have to find out 2V6 plus 3V7. Now to do that, first of all we will write the V6 and V7, V6 element, V7 element. V6 elements are 1, 2, 3, V7 elements are 0, 1 and 4. Then we have to write 2V6 plus 3V7, that will be 2 into V6 elements. V6 elements are 1, 2 and 3, plus 3 into V7 elements. V7 elements are these, that is 0, 1 and 4. Now we will be multiplying 2 inside this one, so it is going to be 2 1s are 2, 2 2s are 4 and 2 into 3 will become 6. Plus now we will be multiplying 3 inside, so 3 into 0 is 0, 3 1s are 3 and 3 4s are 12. Now we will be adding these two as we have done earlier. First element will be added with the first one, order wise we are going to add them. 2 plus 0, second will be added with the second element, 4 plus 3, and third will be added with the third one, that is 6 plus 12. Now if we simplify this one, it will be 2, 4 plus 3 is 7 and 6 plus 12 is 18. This is answer of 2V6 plus 3V7. Now we have understood how to add two vectors, how to subtract two vectors, how to multiply by a scalar number, and this one was a combination of the previous two. Now next thing which we are going to intend to do that is to check whether the given set of vectors are linearly independent or not. Now when it comes to set of given vector to be linearly independent, suppose we have been given m vectors. Suppose v1, v2, vm are m vectors given to us of same tuple. Now we have to check whether these vectors are linearly independent or not. In that situation, we have been given m vectors, so we will be taking m constants. Let us take k1, k2, k3, km. These are vectors of n tuples. These are km, that is the m constants, that is we say as scalars. Then we will be having one equation, that is a linear combination, that is k1 v1 plus k2 v2 plus, here we can have v3 also because we have written here k3, so k3 v3 plus plus km vm, comparing that with a zero vector. Here zero vector is also of n tuple, and if after solving this one, if all ki's from 1 to m, that is k1 is equal to k2 is equal to k3 is equal to is equal to km, and that is equal to 0. Here we will write all ki is equal to 0 for I is equal to 1 to m. Now, suppose by solving the equation which we will get from here by evaluating that, comparing with the elements order wise. Now, suppose any of these given k to km becomes non-zero. If all are 0, then it is linearly independent. If any of them or at least one of them becomes non-zero, then the given set of vectors will become linearly dependent. Always remember, if any of these given k2, k3, km becomes non-zero, then this given set of vectors v1, v2, vm will become linearly dependent. So that is the difference between linearly independent set of vectors and linearly dependent set of vectors. So definition is little different, so you need to be very careful when it comes to linearly dependent. Then here you will have at least any one of the at least one ki is non-zero. Here all ki's are 0. In the case of independent, if at least one ki is not 0, then the given set of vectors will become linearly dependent. Now we will be having one sum to make the concept much more clear. Let v1 is equal to 1, 0, 0, v2 is equal to 0, 1, 0, and v3 is equal to 0, 0, and 1. Now check, we have to check whether v1, v2, v3 are linearly independent or not. Linearly independent or linearly dependent. Now to do that, in the solution we have been given v1, we have been given v2, we have been given v3. We will copy those things. That is the first step. 1, 0, 0, 0, 1, 0, and the v3 is 0, 0, and 1. Now there are three vectors, so we will take three scalars. Let k1, k2, and k3 be three scalars such that now when it comes to that condition, that was k1 v1 plus k2 v2 plus k3 v3, that will be equal to 0 vector. We are having three vectors, so we have taken three constants, and we will take the linear combination of that and compare with that with the 0 vector. If there are 4, so we will be having k4 v4 also. So that depends upon the number of vectors given to you in the question. Now k1 into v1 is 1, 0, 0, plus k2 into v2 is 0, 0, 1, 0, and k3, that is your plus sign, k3 into 0, 0, and 1, that will be equal to 0 vector. See, these vectors are of 3 tuples. Given vectors are, these are 3 tuples. So our 0 vector will be also of same size, same format. So it is going to be like that. So we will simplify this one. K1 will go inside. It will become K1, 0, 0 plus K2 it is going to be 0. First element is 0, 0 into K2 will be 0, and K2 into 1, then again here K2 into 0 will be 0, plus 0, 0, and K3, that is equal to 0, 0, and 0. Now we'll be adding, the first will be added with the first element in the all the three vectors. So we will be having K1 plus 0 plus 0. Then we will be having second element here. All the second elements will be added together. That is going to be 0 plus K2 plus 0. And third element we will be adding. This is 0, 0, and K3. So it will be 0 plus K3. That is equal to 0, 0, and 0. Now if we look at this one, simplify this one, it will become k1, this is second one is k2, and third one is k3, and we got that is equal to 0, 0 and 0. Now when we do the comparison, at the time of comparing the two vectors, we will be comparing the first element with the first element, second element with the second element, and third will be compared with the third one. When it comes to equality of two matrices, the corresponding element need to be same. So what is going to be k1? k1 is equal to 0, k2 is equal to 0, and k3 is equal to 0. So all the constants are 0 now. Since all scalars are 0, therefore given set of vectors are linearly independent. Next time we will be having few more sums on this.